Good morning, students. Welcome to the class on organometallic chemistry. We were discussing Grignard reagents. Yesterday, we have seen how Grignard reagent reacts with carbon dioxide. Similarly, Grignard reagent will also react with carbon disulfide. When Grignard reagent is reacting with carbon dioxide, it generates carboxylic acid. Here, Grignard reagent reacts with carbon disulfide in a similar fashion and it generates dithionic acid. Dithionic acid. It is similar reactivity to carbon dioxide. Similarly, Grignard reagent will also react with isocyanates. Isocyanates. Here carbonyl carbon is the positively charged carbon. This is partially negatively charged. This is again partially negatively charged. So RMGX will attack an partially positively charged carbon. Then this carbon nitrogen double bond will be polarized towards nitrogen. So the product is RNH. For differentiation, I'll make it R dash. So it becomes R dash NH. Then we have C double bond O. Then whatever the Grignard reagent is there, it is the R. So we have generated amide. Amide. So Grignard reagents react with isocyanates to generate amides. Similarly, Grignard reagents will also react with sulfur dioxide. So what we will get is sulfonic acid. What we are getting is sulfonic acid. What is the product here? There is a correction. This nitrogen is partially negatively charged. Nitrogen is partially negatively charged. Only carbon is partially positively charged. Both oxygen and nitrogen are partially negatively charged due to their high electronegativity. When alkyl halide is treated with magnesium, we generate Grignard reagents. So just insert magnesium between this carbon and halogen. Now when this Grignard reagent is treated with ester, Grignard, if you have one equivalent, ester will give you ketone. If we have two equivalents of Grignard reagent, then that will give us an alcohol. Because here the two Grignard reagents are in the same compound, what we will get is we will get a cyclic alcohol. 1, 2, 3, 4, 5 carbons from Grignard reagent and this carbon, ester carbon. So total 6 carbons. And on the ester carbon, we have methyl group, and this carbonyl will be converted to alcohol. Give the product. When a nitrile is treated with one equivalent of Grignard reagent followed by dilute acid treatment, what we will get is we will get a ketone. This is a methyl group. Nitriles in nitrile, carbon is partially positively charged, nitrogen is partially negatively charged. So this methyl anion will attack on nitrile carbon, then one of the pi bond will be polarized towards nitrogen. So the product here is it becomes minus, then MgBr plus. Then when we add dilute acid, it will be hydrolyzed to carbonate. Here, this is a stable intermediate. This ammonium ion is a stable intermediate. So no further addition of Grignard is possible. Because there is no further addition of Grignard reagent, this ammonium ion will be hydrolyzed to carbonyl. So when we treat nitriles with Grignard reagents, we will have addition of one equivalent of Grignard reagent that leads to carbonyls. If it is an alkyl nitrile, we will get ketone. If it is HCN, we will get aldehyde. Here, one of the alkyl halide will be converted to Grignard reagent, and that Grignard reagent will undergo nucleophilic substitution and another alkyl halide. So we will get a cycloalkane. How Grignard reagents react with amides? This is NN-dimethyl formamide. In short, we call it as DMF. When we use only one equivalent of Grignard reagent, one Grignard molecule, one alkyl anion will attack an amide bond. Say for example this CH minus and this is plus. When one equivalent of alkyl anion is attacking here, this N group will be leaving. So what we will get is, this is from Grignard reagent and this is from amide. So when we use DMF formamides, we will get aldehyde. Similarly, when we use some alkyl amides, then we will get here this pH minus will attack an carbonyl carbon. So this NMU2 will be leaving. Here what we will get is pH from Grignard reagent and COCH3 from amide. So obviously the product is, when we use some formamides, we will get aldehyde. When we use some alkyl amides, we get ketones. This is benzaldehyde, this is acetophenone. So when we use only one equivalent of Grignard reagent and an amide, we will get carbonyl. So all these carbonyl molecules, when we use only one equivalent of Grignard reagent, they generate carbonyls. They generate carbonyls, either aldehydes or ketones. But when we use two equivalents of Grignard reagent, yeah, we know Grignard reagent can also attack an carbonyl, that means ketone or aldehyde. So it is possible to use more number of Grignard reagents so that the generated ketone or aldehyde will further undergo Grignard addition to give tertiary alcohols. What is the product here? We get tertiary alcohols. It depends. If it is aldehyde, we will get secondary alcohol. If it is ketone, we get tertiary alcohol. Give the products in these reactions. When this lactam is treated with excess of methyl magnesium bromide, what is the product? When this beta ketoester is treated with one equivalent of Grignard reagent, what is the product? when it is treated with excess of Grignard reagent, what is the product? When we don't want to involve this ketone in Grignard reagents, it is possible for us to protect the ketone in the place of ester. So when we treat with 1,2 ethane diol under acidic conditions, carbonyl will be protected. So we are left with only ester group. Then ester will involve in reaction with the Grignard reagent, and finally when we do acidic hydrolysis, then what is the product? I'll give the first step. When we protect carbonyl ketone with 1,2-ethane diol, the product is this one. Then when we treat it with excess amount of MgBr, what is the product? When we treat amides with excess Grignard reagents, one equivalent will generate ketone, another equivalent will generate alcohol. So here the product is, generally this group is, amine group is to be a leaving group, but it is a cyclic system, so it will be there. Then on the other side, what we will get is addition of two methyl groups to generate this tertiary alcohol. Amine also will be there because it is a cyclic system. In this case, when we use only one equivalent of magnesium, methyl magnesium bromide, among ketone and ester, ketones are more reactive compared to esters. So ketone will involve in Grignard addition. So what we are getting is this tertiary alcohol. But when we use excess amount of Grignard reagent, then ester also involve in Grignard additions. If ketone involves in ester Grignard addition, this is the product. If ester involves in Grignard addition, of course we can add two equivalents of Grignard reagents, on ester. So what we will get is this tertiary alcohol. Now, in the next problem, when excess amount of Grignard reagent is added to the ester, as I said here, we will get a tertiary alcohol like that. It is pH phenyl Grignard. So we will get a tertiary alcohol of this kind. When we treat this under acid and thermal conditions, this acetal will undergo deprotection, so carbonyl will be regenerated. Then this alcohol will undergo dehydration to give this product.